Okay, welcome back for Lesson 2. This is Unit 1, Lesson 2, titled Order of Operations. We talked a little bit about order of operations in Lesson 1. Today we're going to cover it a little more extensively, a little more in depth. Okay, your one objective today is to use the order of operations to evaluate expressions. Remember we talked about what evaluate means yesterday. It just means we're going to solve. Okay, so let's go ahead and jump right into it. Okay, first let's talk about why you even need an order of operations. Okay, let's say that I gave you this problem, 4 plus 1 times 2, and we didn't have an order of operations. Okay, well, if we didn't have an order of operations, most likely you would just solve this like this. You'd go 4 plus 1 and get 5 times 2, and 5 times 2 is 10. Now why would we solve it that way? Well, because we read from left to right. So we would start at 4 plus 1 and get 5, then do times 2. Okay? Well, there are some countries that read the other way. They read right to left. Okay, so let's say they solve the same problem. Well, they read right to left. So first they would do 2 times 1 and get 2, and have 4 plus 2 and get 6. Okay? So what's the problem? There's two different answers. Okay? Now we need math to be a universal language. I mean, everybody's got to speak the same language when it comes to math. Okay? So we can't have something like this where we get two different answers for the same problem. It doesn't work like that. Okay? Math cannot work like that. Everybody's got to be able to get the same answer. So somebody somewhere, I don't know who it was, but some smart person out there, or somebody who was just really bored, came up with this order of operations, saying we're going to do these things in this order. Okay? So let's discuss this a little more. Okay, so here's our order of operations. Okay, it's called PEMDAS. Okay, another way to remember that is please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Okay, and here's what everything stands for. We've got parentheses, we've got exponents, we've got multiply, we've got divide, we've got add and subtract. Okay, now important things. Okay, we'll talk about parentheses in just a minute, something that's important with them. But for now, we'll stick with these. Multiply and divide go together from left to right. Okay? You'd always do multiplication and division. Look at them together. Okay, from left to right. So if multiplication's on the left, and then there's a division, you do the multiplication first. If division is farthest left, and then there's multiplication, you do the division first. Okay, it's left to right. Same thing with add and subtract. It's left to right. Okay? So really, you've got parentheses, exponents, then multiply and divide go together, and then add and subtract go together. Alright? Now, let's talk about the parentheses here. Parentheses don't just include parentheses. Okay, parentheses are considered grouping symbols. So parentheses can be parentheses, they can be brackets, or a division bar also counts as grouping symbols. Okay. Now when we talk about parentheses and brackets, sometimes you might get something, or you work on those from the inside out. Okay. Oops. Inside out. Okay. So if I get something that looks like this, what I mean by inside out is I'm going to do the parentheses first and then finish the brackets. Okay, so I'm going to finish everything inside these brackets first, but when I look in the brackets I got to do the parentheses. Okay, so make sure that you're keeping that straight. So parentheses include parentheses, brackets, and division bar. Really it's just grouping symbols. Okay, so just got 3 examples for you, I think. Here's the first one. Remember, first thing we look for, so we got PEMDAS. So first thing I'm checking for is parentheses. Okay? Remember, parentheses means grouping symbols. So if I look at this, I've got a big bracket right here. I need to do everything inside of this bracket before I can add 15. Okay? So looking inside the bracket now, what do you notice you got? Well, I've got some parentheses here, so I'm going to take care of those first. 7 minus 4, that's 3. Then I keep everything else. Squared plus 3, and I've still got brackets around that, plus 15. Okay? Still working on the P, the parentheses, but grouping symbols, okay, because I still got grouping symbols, I still got brackets, so I still have to look inside those grouping symbols. But when I look inside the grouping symbols, I notice that next I've got an E. I've got an exponent right here, 3 squared. So I need to do that. 3 squared, 3 times 3, that's 9. Still got plus 3 in my brackets, plus 15. Make sure, by the way, you are writing down your steps and showing your work all the way through on these. I expect to see this work on your assignment, not just final answers. If you write just final answers, you will get 0 credit and you'll have to redo the entire thing. Make sure you're showing all your work like I am. Okay? Oh, I still got my brackets there, but I'm finally able to finish them because I only have one operation inside the brackets. I got 9 plus 3. That is 12. Now I don't need the brackets anymore because I finished them. They're done. And then 12 plus 15 is 27. Answer circled or boxed. Okay? So there's your first example. Let's go on to another one. So again, we're still talking about PEMDAS. This example, you're going to look at this and say, well, I don't have a P because there's no parentheses. Remember, parentheses include parentheses themselves, they include brackets, and they include fraction bars. I've got a fraction bar right there. Now what the fraction bar acts like is it splits the problem into a top and a bottom. So really it's like putting parentheses on top and parentheses on bottom. So we got to solve these as two separate problems and then combine them at the end. Okay, so let's do the parentheses on top first. 13 minus 4, that's just 9 over, okay, and then I'm still going to have all this stuff in parentheses on the bottom. Okay, so I finished my parentheses on the top. Now I got to worry about the bottom parentheses. Well, in those parentheses, I notice I've got exponents right here, so I'm going to do the exponents. Keep my parentheses. 18 minus 4 squared is 16. Okay, so now I've got 9 over 18 minus 16 plus 1. Okay, so I'm going to have 9 over. Now, what do I do next? The subtraction or the addition? Well, right here, the A comes before the S, but that does not mean that I do addition first. Remember, those go together left to right. So the subtraction problem is the farthest left, so I do that first. So 18 minus 16 is 2. Okay, so now I've got 9 over 2 plus 1. You've got to finish the parentheses on the bottom still. 2 plus 1 is 3. Now I've just got this problem left. 9 divided by 3 is what this means. 9 divided by 3 equals 3. Okay, again, don't forget to show all your work like I am showing. Do not just give me a problem where you just write down the final answer of 3 after you did it on your head. Okay, it's not going to cut it. Alright, let's go on to our last example. Okay, last example. This one I made up here for you. 9/10 times y minus 3/10 when y equals 1/2. So now, again, we've got variables, so we're evaluating, meaning I tell you y equals 1/2, you plug it in whenever you see a y. So 9/10 y means 9/10 times y. So I'm going to rewrite this. 9/10 times my y value, which is 1/2, minus 3/10. So I've got two operations. I've got times and I've got minus. Okay, what do I do first? Please excuse my m multiplication comes first. So I'm going to multiply these fractions. When I multiply fractions, I multiply across the tops. 9 times 1 gives me 9. And then I multiply across the bottoms. 10 times 2 gives me 20. Okay? Now I've got a subtraction problem. I cannot subtract fractions without a common denominator, so we got to switch these to common denominators. Well, you should be able to look at these two and tell me that your common denominator is going to be 20. Okay? All algebra students should be able to do that part in their head. Well, I didn't change the denominator over here, so I can't change this numerator either. It's got to stay the same. But I did change this denominator. I got from 10 to 20 by multiplying by 2, so I have to multiply the numerator by 2 as well. 3 times 2 is 6. Okay? And now I can subtract these. When I add and subtract fractions, my denominator does not change. Too many people forget that. Denominator does not change when you add and subtract fractions. That's why we have to make it a common denominator in the first place. Okay, and then 9 minus 6 is 3. Whenever you have a fraction, always check to make sure it's simplified. 3/20ths is simplified. Answer, done. Bada bing, bada boom. That's the example. Okay, and that's your notes for the day. So again, good luck on your order of operations assignment.